solving exponential equations. An exponential equation is an equation where the variable x, or whatever variable you need to solve for, is in the exponent. That makes it an exponential equation. The way that we solve an exponential equation is with logarithms. Because logarithms, the key log law that we have is this one. Log a of m to the n equals n. And what that does, what that log law does, is it takes something that's an exponent and moves it out of the exponent spot. And as soon as you move it out of the exponent spot, you change the question into an algebra question you've already solved before. So when solving these equations, and there are more than one way to solve an exponential equation, but the technique that we're going to use over and over and over again is, first of all, we're going to take the logarithm of both sides. So again, you don't need to write this down. These are all your steps that you have in there. So what does that do? Well, if I take the log of this side and I take the log of this side, then they're still equal. Does it make sense that it would still be equal? Because now the 2 to the x is equal to 3. Now they're both inside the logarithm. But now we have the log law that says if I have an exponent, I could bring that out in front. So if I do bring that out in front, okay, then I get x log 2 equals log 3. Now, something that gets harder to do as you get more advanced in mathematics is recognizing a number, right? Like in grade 1, they did stuff like this. Is this a number? You would say, no, that's a letter. Then be like, what about this one? Yes, that's a number. You knew what a number was and you knew what a letter was, right? Why does it get harder, right? You're in grade 12 now. Huh? Is that a letter or is that a number? It's both. Ooh. Okay, so we get some messy stuff. Okay? Log of 2. That's a number. Log of 3. That's a number. You can't tell me off the top of your head what those numbers are. Or did anybody in their past have to memorize logarithms in their school? Okay, no. Sometimes I get a student. Sometimes I get a student from a different country. I had a student once come from India. She said, I had to have log of 2 memorized. She said, it's 0.201. Oh, I don't know. I think I'm wrong, but that would be scary. 0.301. Oh, I was close. Okay, I got to work on that. Then I have at least one log memorized. Okay? Yeah, so she said it's 0.301. Why do you have to memorize that? I don't know. We had to. But this is a number, and this is a number. If they're numbers, you know how to solve questions like 3x equals 7. You know how to solve that. Just have to divide by the number on both sides. Well, if you recognize that these are numbers, you can now divide both sides by log of 2, and your answer is log 3 divided by log 2. Put that into your calculator. Log 3 divided by log 2. So exciting. 1.58. These are always calculator questions if the bases aren't the same. Remember, we solved exponential equations before if you could get the bases the same with your powers chart. If the bases can't be put the same using your powers chart, it's always a calculator question. And the beautiful thing about calculator questions is you can always check if you're right. You can also always find out if you're wrong, which is sometimes disappointing. But if you check and you find out you're right, you're like, yes, I got that question. I can move on. So how do we check that it's right? Well, with a graphing calculator and with a scientific calculator, there should be a button that allows you to store your answer as something. Sometimes it's M+ for memory. On the graphing calculator, it has a store button. If I hit the store button, it says, where would you like to store your answer? And you could pick any letter you wanted. I often just pick X. So now, on my calculator is remembering that X is 1.58. What was my original equation? My original equation was 2 to the X equals 3. Well, let's check if we got it right. If I go 2 to the power of X, and I push enter, if I did all the math right, it should tell me 3. If I made a mistake, I'm going to be disappointed and have to redo everything. This is always nerve. Oh, whew. Good. It's right. So we can use, okay? So recap, I didn't finish writing steps as I did it. I just did it. We took the log of both sides. Then we use our log laws to get the x out of the exponent. In this case, we could do it right away. Sometimes you can't. Sometimes you have to use more than one log law. Sometimes you have to expand completely. So one of the skills that we learned, that we've been practicing, is expanding completely. Why do we need that? Well, we need it for exponential equations. And then you just have to solve once you've done that. So this is the most basic one of using those steps. Okay? That's not the only way you could do this question. With logarithms, sometimes there's more than one way. For example, just using the definition. If your calculator lets you do different bases, hey, if I use the definition of a logarithm, and I change this from exponential form to log form, what's the base? 2. What's the answer? 3. What's the exponent? X. And if you can type log base 2 of 3 into your calculator, boom, you get the answer right away. That seems a lot shorter, but I'm going to say for all questions using a calculator, we're going to want to use this method just because it works all the time. Okay? Now, I put log here. I'd like you could also use the natural log. You could use the log of any base you wanted. But since calculators have log and natural log, those are the ones you should do more often. So, example 2. Solve for x. Okay? I'm going to show you a couple of different things with this one. Again, you can use the steps for solving for logs. So I'm going to do the most common one first. Then I'm going to do it in natural logs, the most common way. Then I'm going to use some other algebra skills that I already have and do it that way as well, just to see some different strategies. So the most common way is students would start with taking the log of both sides, because that's what. So I took the log of both sides. Logarithms are, as far as the marking goes for solving exponential equations and using logarithms. If you make up a log law, you think, I'm going to use something other than the 3 that are there, the marking stops there. So then it's sort of like, oh, everything after this is wrong. You made up a log law. So I encourage you not to do too many steps at once. Okay? Most common mistake here is people bring the x out right away. Okay? Sometimes on the final exam, they give you 1 mark for taking the log of both sides. And I've seen students who skip the step and put the x out in front right away, which is a mistake. And then they don't even get the mark for taking the log of both sides because they made a mistake in their first line. So what do we want to do? We take the log of both sides. Now it says use your log laws to get the x out of the exponent. Why am I not allowed to use the x out in front? Because that log law, if we look at it right here, the n can come out in front if it's the exponent to the entire thing that it's inside. But if we look at our example, the x is an exponent just to the 3. The x is not an exponent to the 2. Am I allowed to do 2 times 3 and get 6? No. That would go against order of operations. You can't multiply before you apply an exponent. But what I can do is say, hey, this is 2 times 3 to the x. I have a log law for that. If I'm expanding completely, I'll first add. And then I could bring this x out in front. So I'm going to do that. I'm also going to move the log 2 to the other side. Because those are just numbers. If I want to get x by itself, I want x all by itself on one side. Log 3 is a number, so I can divide. So I'm going to use the fraction button on my calculator. That way I don't have to add extra brackets. Log 5 minus log 2 divided by log 3. 0.834. Again, whenever you get an answer with a log question, you're going to want to check, did I get it right? So I'm going to store this as x. My original equation was 2 times 3 to the x. So I'm going to check, what is 2 times 3 to the x? If it's equal to 5, we're good. If not, we have to start over. Got a little cold sweat there, nervousness, but it worked out again. So this is the most common way to solve this one. Taking the log of both sides. This is what's written in your notes, and you're just watching. So now I'm going to do the same question again. And I'm going to show you, since you have a natural log button on your calculator, that you could have taken the natural log of both sides. And then, since it's multiplication, the rules are the same with natural logs as they are with actual logs. And now this exponent could come out in front. Move the natural log of 2. That's a number. Recognizing that those are numbers, and divide by the natural log of 3. And if everything works out, I should get the same answer. But I used natural logs instead of logs. Let's double check on our calculator. Natural log of 5 minus natural log of 2, divided by the natural log of 3. Do I get the exact same answer? I do. View, zoom, entire page. Okay, so we can see them both there. First of all, can you see that they're basically identical, these strategies, using log or natural log? They're interchangeable. Not a single step was different if I used log or natural log. Okay? If I can think of one advantage, you're going to probably save, if you use natural logs, you're going to probably save maybe, I guess, 35 milliseconds, maybe 72 millis, I'm not sure. Because what, look, here you have to write 3 letters, and here you just have to write 2 letters. So in this question, using natural logs, I saved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. That solution is 11 letters shorter. I don't know how much time it takes you to write 11 letters. Probably not very much time. But it does save you a tiny bit of time using natural logarithms. Probably not noticeable. Despite that, most students like to use the word log over natural log. Maybe because in their head they say natural log, and it takes longer to say natural log than it says log. So maybe that cuts out the savings of time. Okay, so those are the common ways using log and natural log. One more time I'm going to solve this. Okay, we've got here's the original question, and before I take the log of both sides, I'm going to use some of my previous algebra skills. Can you see that I could get the exponent all by itself, right? What would I have to do to get the 3 to the x all by itself? Divide by 2. Okay? What you do to one side of the equation, you do to the other side of the equation. So if I divide both sides by 2, you could write it as a fraction or you could write it as a decimal, 2.5. Sorry. My prejudice is showing. I like fractions better than decimals. Don't judge me. Okay? 5 divided by 2. Now, you could take the log or the natural log of both sides. Log of 3 to the x equals log of 5 over 2. Can you see now I would be allowed to bring this out in front right away? So I would get x log 3 equals log of 5 over 2. Oh, there's so much fun math. Divide both sides by log 3 since it's a number. Check it on your calculator, and we should get that same answer again. So, log of 5 over 2 divided by log of 3. Do I get the same answer? I do once again. So the nice thing in this one, we had to use less log laws, right? We didn't have to use the adding log law to figure it out. Gave us the same answer. Here is where you got x by itself, right? Log 5 over 2 divided by log 3. Why are those the same? There's your log law, right? Subtracting is dividing. So if you do one way, you're going to get subtracting to show up. If you're going to do the other way, you're going to have dividing show up. But they're exactly the same thing. So it makes sense why the answers turn out that way. Well, I took a long time on that question because I wanted to show you you could use natural logs instead of logs. I wanted to show you that if you wanted to do some simplification with algebra first, you can, right? It's part of your algebra rules, right? Any rules that you've learned in math, you're allowed to use them. Just don't make up new rules. That usually ends up being a bad thing. Okay, and now, the most complicated questions is when there's an x in an exponent on both sides. First of all, this would be a calculator question because you can't get the base of 5 and 3 to be the same. They're not on your powers chart. So that's something to always check, because if you can do it without your calculator, it's better. Okay, so for this one, step one, oh, this one's going to be long. I'm going to save some letters. Are you okay with this? If I do the natural log instead? Right? Just so my YouTube video isn't quite as long. Here we go. Take the natural log of both sides. Notice that this exponent is to the entire thing, so it could come out in front. This exponent's to the entire thing, it could come out in front. Now I'm going to make a small mistake, see if you can see what it is. I'm going to bring out the x minus 1, and I'm going to bring out the 2x plus 3. I made a small mistake. What's the small mistake? I need brackets around these. Why? Because whatever gets brought out in front multiplies that. But if I don't put the brackets, mathematically I'm just saying just the 3 multiplies or just the 1 multiplies. So we need, when that whole thing comes out in front, it needs brackets. Is natural log of 5 a number? Yes. What do you do in algebra when you have a number? Pick a number you're more familiar with. 7. If you had a number in front of brackets, x minus 1, what would you do with that algebraically? You'd distribute, right? You'd do 7 times x and 7 times minus 1. So what we do with regular numbers algebraically, we do with not nice looking numbers algebraically. So I'm going to distribute. I'm going to distribute the natural log 5 to both of those. I'm going to distribute the natural log of 3 to both of those. What is that going to give me? It's going to be x natural log of 5 minus natural log of 5 equals 2x natural log of 3 plus 3 natural log of 3. So I just distributed. What do I want to solve for? I want to solve for x. So algebraically, when you had multiple x's, you like to say, oh, I'm going to get all my x's on one side and all my numbers on the other side. We're going to do the same thing here. I'm going to get all my x's on the left-hand side, so I have to subtract 2x natural log of 3 to bring it to the left-hand side of the equation. I'm going to put all my numbers on the right side, so that's 3 natural log of 3, and I'd have to add the natural log of 5 to the right. Now this is where what you did with nice numbers is going to be a little bit different when working with not nice numbers. Okay? What did you do with nice numbers? If you had this, 2x plus 3x equals 7, what would you do as your next step? Combine those and write 5x? Would you do that? Right? You would just combine those and you'd be mental math, have no problem writing 5x. How's our mental math here? Not good. X natural log of 5 minus 2x natural log of 3. Not good for mental math. So what we do instead is something you could have done with this, but you never do it. Does anybody ever go, oh, there's a common factor of x here. I'm going to factor it out, leaving me with 2 plus 3, which happens to be 5. Can you see I could factor that x out? Would that get the x all by itself? Yes. And leave me with 2 plus 3, which is 5? Yes. So we are going to do the same thing here. To get the x by itself, we're going to factor. We're going to say there's a common factor of x in both of those. I can factor that x out, leaving me with natural log of 5 minus 2 natural log of 3. Inside the brackets is a number. It's not a number that I can mentally see easily, combine easily, but it is a number. So how would I get x by itself? I would divide by that number. And now we can type that into our calculator. 3 natural log of 3 plus the natural log of 5 divided by the natural log of 5 minus 2 natural log of 3. Negative 8.35. And once again, we can find out if we were right. How do we find out if we were right? We're going to take that answer. I'm going to store it as x, put it into my calculator's memory, and then I'm going to go back to my original equation. In my original equation, the left side was 5 to the x minus 1. So I'm going to type 5 to the x minus 1. I get 2.936 e to the minus 7. Okay. Does that match with my right side? Well, my right side had an x too. So I'm going to type that into my calculator. 3 to the 2x plus 3. This is the nervous part. If it matches up, we know we've done everything right. If not, what have I done? Wasted 10 minutes of your time? Oh man, that makes me feel more nervous. Oh, good. They matched up. So the left side is the same as the right side for that value of x. Then we know we've got it right. Wow, lots of writing for these log questions. Okay, using natural log on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I saved 20 letters using natural log over log. Right? Write out the letter G 20 times. See how long it takes you. That's how much time I saved. Yes? You can use natural log instead of just normal log for the same reason that logs of any base all follow the log laws. Okay? So a log with any base, all the log laws work. A natural log is just log with a base e, but you don't, instead of saving that, you just write ln. Okay? So because of that, step 1, taking a log of both sides, if the insides are the same with the log on the outside, it's still going to be the same. Then all of the rest is just log laws and rearranging in algebra, so it doesn't matter what base you use. Okay, so on the back side of the quick review of log laws, there's exercises, one question that goes from A to I. Those are ones where you're using these. So what we're going to do right now is we're going to work on those. If you have finished those already, because I think there was a couple of people that did finish those, if you want to go to section 5.7, in your textbook, you can do questions 7, 8, 10, and 12.